Where the graph intercepts the x-axis is going to be at 0, 0, and 130, 0. State what these two x values represent. Okay, well, when we're trying to state what things represent, we go back and say, okay, well, x represents the length. X equals length. So they represent the length of this. So when x, or when length, is 0 centimeters or 130 centimeters, the area is 0 centimeters squared. Okay, so when it's asking for representations, what it means in the context, all you need to say is when this is this, then the other thing is that. When x is 0, but the context, so when the length is 0 or 130, then the area becomes 0. Hence, find the equation of the graph's line of symmetry. This is your axis of symmetry stuff, right? We know that these 2 points are reflected across the axis of symmetry and their x values. So in order to find the axis of symmetry, we just need to find out what their average is. So go ahead and do that on your own. Just halfway between. State what the equation of the line of symmetry tells you in this context. Your axis of symmetry is super important because it goes through what super important point? Your axis of symmetry gives the vertex. It goes through the vertex, and we love the vertex. We want to talk about the vertex all the time because the vertex is when things are maximized or minimized. And more often than not, when we've created a relationship, we want to know when has it gotten to the most that it can be and when has it gotten to the least that it can be, because it tells us how we can optimize that situation. And that's going to be a lot of what calculus is. How can we optimize this situation? A lot of what we're talking about right now will be used in calculus as well. So it gives us the vertex. Well, it gives us the x value of the vertex, right? So we know 65 and then y something, but we know that it's been maximized, and we found it with the range, but that doesn't really matter right now. We know that at 65, the area has been maximized. And so that's what the axis of symmetry tells us, is it tells us at what x value we have the vertex. Whether we're talking about a maximum or a minimum, the axis of symmetry tells us when we will have optimized or maximized or minimized this situation. So at 65 centimeters, we have maximized the area. Okay. So a little bit different of a way to create a model. Definitely difficult. This is something that's really hard to wrap your brain around at the beginning, but once you kind of understand that idea of you establish a relationship that you know to be true, that's been true for all the times you've been taking math, and then try and figure out how do I eliminate multiple variables and only get down to one variable in order to make it an input of only one. So this is something that will happen, that we get through. When we figure out the procedure and the process, it'll start to become like your favorite thing because you can do it over and over again. But piano, we'll get there. The Sydney Harbor Bridge is supported by 2 spans that can be modeled by quadratic functions. The lower span is approximately 503 meters wide and 818 meters tall at its highest point. Develop a quadratic model for the lower span such that one end of the span is positioned at 0, 0. This is the second way that we would be creating a model, quadratic specifically, because this is what we're talking about. But as we move forward with other models, we'll see that this is consistent. These procedures are consistent. So one way is that we establish a relationship that we know to be true, replace one of the variables by doing substitution, and then you only have one input. And this is what we practiced in 9.1, which is that we were able to grab points and create systems of equations. First things first, always draw a picture. We're talking about a bridge, so a bridge looks something like that. The lower span means like you have a bridge bottom and you have a bridge top, and it's talking about the lower part of the bridge. So that's the vocabulary there that you might not understand. But we're just talking about the lower part. And it says that it is approximately 503 meters wide and 818 meters tall. If it wants us to put the one end of the span at 0, 0, that means that our equation of the quadratic is going to look something like that, which means we can start picking out a few key points. This, for instance, is one key point. This point we can also figure out right away. I want you to go ahead and tell me what you think that point is. We have been told that this spans 503 meters, which means that this guy is 503 away from the origin. So that has an x value of 503 and 0 as our xy value. We are then told that that is 118 meters tall. So if we know the height, how tall it is, that gives us the y value. We also can figure out the x value right away based off of what our x-intercepts are. Go ahead and see if you can figure out what the x value is. Your x value here for the vertex, where your axis of symmetry is the average between your two x values, right? So we just need to figure out what is halfway between 0 and 503. In other words, what is 503 divided by 2? It is 251.5. So that's the equation of our vertex. And notice with the parameters, I have 3 unknowns, and I need 3 equations in order to solve for 3 unknowns. We know that C can be found with our y-intercept. And we have our y-intercept. It's right here. So right now we can tell that C is equal to 0. You could also just plug in the point. 0, 0. Boom, which looks like a face. 0 equals a times 0 squared plus b times 0 plus c, and we get 0 equals c. It's your y-intercept. Okay, we just solved for c. Boom, done. Now we have 2 parameters. We need 2 equations to create in order to solve for those 2 unknowns. We've solved for c by plugging in one piece of information. We're going to plug in the other 2 pieces of information to get for a and b. Okay. Let's do 503, 0. 0 equals a times 503 squared plus b times 503 plus c, which is 0. Go ahead and we'll just do it together. 503 squared is 253,009, and there's an a there, plus 503b. So I just created an equation that involves a and b. 2 unknowns. Right now I only have one equation. Okay, so I need to plug in another point in order to create my second equation. That's 251.5, 118. You end up getting a pretty long decimal, I think, if I remember correctly, for this guy squared, but that's fine. Just, well, let's go see. Let's look at it together. Oh, not too long of a decimal. Go ahead and write it with the 0.25. So 63,252.25 A. Finish the equation. And now you have your second equation. You have enough information to solve for a system of equations. System of EQs. Go ahead and plug this into your calculator to solve for your system of equations. For those of you that don't remember, you need to be in the calculate section of your calculator. We're going to algebra because we are performing algebra by doing a system of equations, and we're solving systems of linear equations. This is linear because notice we don't have any exponents, we don't have any fractions. Okay, you plug in those values, type them in exactly into your calculator, you press enter, and we get that A is equal to negative 0.00187. Maybe. Let me double check that because I don't think I kept the values exact in my answer key. So let me double check. One, 8. Yeah, still works. Okay. And then B is equal to 0.938. So we've now solved for A, B, and C, and the very last thing that we need to do is just put it all together in an equation because it asks us to develop a quadratic model. In other words, develop a quadratic equation. F of x equals, instead of a x squared, we do negative 0.00187 x squared plus bx plus c, which is 0. And now you've created a quadratic model that represents the arch of the bridge. And that's it. If you're talking about IAs, if you want to look into something like this for IAs, this is what you would do for an IA, is that you would gather information about whatever situation you're trying to model, create a system of points or points that would help you create a system of equations, and then you would use those in order to create a model that represents whatever problem you're doing. Good job.